Hello and welcome to the third and final session of Windows Phone 7 Unleashed. My name is Daniel Egan. I hope you enjoy the session.
Welcome to session 3 for Windows Phone 7 Unleashed. In this session, we're going to be talking about three different things. We're talking about application life cycle is where we're going to start out. It's very important for you to understand how the application is going to react when users navigate away from your application, either forward through your application or back through your application. We're then going to dive into the sensors that are available on Windows Phone 7 and how you can interact with them. And then finally, we're going to end up with launchers and choosers. These are how you can grab data from the phone with the user's consent and utilizing that to then launch other applications, whether it be SMS, email, camera, etc. on your application. So that's what we'll end with in this session. So these are some terms you need to understand when you're working with a Windows Phone 7 application. Application state, which is not just a state of a single page, but state of the whole application. And this is important because when you get out of tombstoning or you leave your application, you only have a certain amount of time, I believe tops 10 seconds, before your application is terminated. And so depending on how much data you're holding in your application, you need to be able to save that quickly. So you need to understand the state of your application and be saving the state of your application multiple times, not just on exit. You need to understand page state, which is the state of obviously a single page. But within that, there's two terms, persistent data and transient data. Persistent data is stuff that you want to be there when they come back to your application a second time, meaning that when they restart your application, you want that data to be there. Transient state is the data that you want to hold to give the illusion that your application is running in the background, and you save that for a single instance of your app, and you can store it in the state dictionary. So for your application life cycle, you have the launching event, which is fired when you first launch the application. You have your running state, of course. You have a closing event when your application is closed. That means it's gone, it's not anywhere on any stack, and you're not going to go back to it. Then you have your activating and deactivating events. And what I'm going to do is go through a user scenario so we understand how your application reacts and what events are actually happening. So the user launches your application right here, and from the start menu or from your live tile or from your application icon, whatever, your launching event will fire. From your launching event, you're going to load whatever data you wanted from isolated storage, whether you saved their username and password through, so they can retrieve that easily with outside different instances of your app. Whatever you need to do for application state that you save in your persistent data, you're going to load here. Again, while you're running, you should save persistent data as much as possible in settings so that when your application shuts down, you don't have to save as much. Now, your user is in your application, and the user invokes a launcher or a chooser. And we're going to be working with this in our application. Launchers and choosers are things like the camera. So if your application utilizes the camera, it is important to know that it is going outside of your application. So your application is being deactivated. Okay? Once that happens, the deactivated event will fire. When the deactivated event fires, you need to save state. If the user instead presses the back button past the first page of your application, the closing event will fire. Now, the best way to think of this is a bucket. You're putting things inside of a bucket. So if a user goes to the start page, goes to the first page of your application, second page of your application, then goes to photos, and then goes to music, and then starts hitting the back button, when they hit the back button to navigate away from a page, that page is gone. There's no forward navigation in the phone. So think of a LIFO. It's taking that page off the stack, and you'll no longer be able to, through the back button, navigate to it. So the difference between closing and deactivating is if you're going forward away from your app and your app has the ability to be reached again by hitting the back button, you're going to get deactivated. If you're using the back button and the user backs past any time where they were in your app, your application will hit the closing event. Okay, so now let's go back to when the user launches the camera. They launch the camera, your deactivated event happens. If the user presses start and launches your application again, you'll start from the beginning, you'll start from the launching event. If they use the camera, grab the picture, and it goes back to your event, the activated event will fire. So remember, deactivated and activated happen when you're still in your app and you get tombstoned because it needs to go outside your app to perform a task, or it goes outside your app to do something else, or they navigate past your app. A closing event will fire when you go back using the back button past the first page of your app. It's also important in this section to notice that if the user presses start and launches your application, once it's already been launched, you skip the activated event. So that's not always going to fire. You'll need to spend some time on the slide, and you'll need to spend some time working with the application to really get a good understanding of launching and closing and deactivating and activating, but this should at least give you a basis of your understanding. Now remember, when we're working in the hands-on lab, we're going to be launching the camera and launching other choosers. The deactivated event and activated events are going to be front and center in those situations. So next we're going to go ahead and talk about sensors. So the phone itself, as we talked about the hardware specification, has 5 sensors. Not senses, although it would be pretty funny to have a smelling sense on the phone. Give a whole new meaning to the fart app. But we are talking about the sensors on the phone, and the ones that come with Windows Phone 7 are light, GPS, which is actually a GPS, which we'll talk about, proximity, accelerometer, and the compass. Now, when we're talking about the specifics of the sensors for the hardware foundation, the GPS is an AGPS, and it's accessible through location. And that's important, as we'll talk about later. It's not in the sensor namespace. And we'll talk about what assisted GPS is also and how that helps you on the phone. It has to be compliant with 3GPP technical specifications and also the supplemental from the Open Mobile Alliance. If you really want to dive deep and get bored, feel free to grab those and check those out. It's got to have an accelerometer that has 3 axes. It's got to have a compass. It's got to have a light, at least one embedded photodiode, and it's got to have proximity, at least one at the top. Proximity, for those that don't know what proximity sensor is, it's a thing that turns off the phone when you place it towards your head and brings it away or brings it back on when you pull it away from your head. Now, you'll notice in orange on the slide that I have either accessible or not accessible on the sensors. That's because at version 1, the only sensors that you will have API access to are the GPS and the accelerometer. Now, there might be a surprise or two that come out, but as far as I know right now, those are the only 2 that you have accessible to you as a developer. They're obviously on the phone, but you don't have API access to the compass, to the light sensor, or to the proximity sensor. So, of course, in this section, we're going to focus on the GPS and the accelerometer. So the location part of the phone starts with the hardware layer. And the hardware layer consists of the GPS receiver, Wi-Fi, and the cellular radio. All of these at the hardware layer communicate with the native code layer. Developers do not have access to the native code layer of location services. Instead, they have access to system.device.location. And through system.device.location, you can write location-aware applications for the phone. Now, it also connects and works with Microsoft services, the location service, the cloud-based service for the phone. And we'll talk a little bit more deeply on that subject in a second here. Now you notice that it said it has to be a GPS. A GPS is assisted GPS, and what that means is that GPS is tough to get a lock on, meaning that if you've ever used any of those running armbands or even GPS in your car, you sometimes have to wait a few minutes for it to get a connection to the GPS satellites. It could be anywhere from 2 minutes to 5 minutes. That's not acceptable for using GPS on the phone. So we use assisted GPS, and we use a service that we have, a web service that we have that utilizes both GPS and Wi-Fi and cell tower triangulation to give you a quicker time to first access. Through all of these means, it allows you to get a point of the phone, get a location point quicker than you would just naturally going to GPS. Now, let's talk about the two forms as a developer you can get through GPS, high and low. Low in the code now is called default. Now, high is GPS. GPS is high in your accuracy. It's really bad on power consumption, really bad on speed, and what I mean by speed is how quickly you can get a GPS signal, and it doesn't work indoors. Cell towers, on the other hand, isn't as good for accuracy, of course. It's really good on power, really good on speed, and does not work too well in the wilderness. Wi-Fi, on the other hand, is kind of right in the middle of all of them. Obviously, it works better in urban areas. Speed, power, accuracy, they're about the same as they would for cell towers. So the choices you have as a developer are high and default. Default will look for a location based on cell towers and Wi-Fi triangulation. It's important to note that if you turn off Wi-Fi on your phone, it won't use Wi-Fi as part of how it gets a location. Now, if you choose high, it's going to look for a GPS fix for your phone. Now, one of the things that's important to note is that if you choose default when you're looking for location when you're building applications for the phone, it's going to first look for cell tower and Wi-Fi, and if it cannot find it, it will degrade upwards to GPS. The same thing happens if you choose high and you're looking for a fix utilizing GPS. If it cannot find one, it will downgrade to the cell tower and Wi-Fi triangulation. So let's go ahead and look at the code to see how that works. I'll go ahead and load up a location service sample. And one of the things you will notice from the sample is honestly how easy it is to get a fix for your application. So I have a regular Windows Phone application. Let me go ahead and show the main page here so you can see its simplicity. I'm going to simply have a couple labels to show me the latitude and longitude of the service and whether the service is on or off. If I look at the code, you'll notice first that I'm using system.device.location. It is not in the sensor namespace. You will find this in system.device.location. I'm going to go ahead and new up a geo-coordinate watcher. The geo-coordinate watcher is the main class you're going to be working with inside of location. I'm going to call it watcher. Go ahead and pop these open. Comment that out. Take that out. I'll show you what that is later. And let me pop this open. This looks like a lot of code, but it's not. So inside my application, I'm using an application bar. And the application bar allows me to turn on high, turn on low, or stop the service. So if we look at the code behind, we have a low button click, we have a high button click, and we have a stop button click. So let's go through as if we were looking for low. When someone clicks the low, we're going to set the text that you see on the device on the screen to power optimized. And then we're going to call this method that we created called start location service and pass it geo-precision accuracy. Now geo-precision accuracy, as I said, has two. It has default and high. So default is the low, which means that it's going to try to find location based on Wi-Fi and cell tower triangulation. If we go to start location service, we're setting the text block. We're actually newing up the geo-coordinate watcher, and when you new up the geo-coordinate watcher, it asks you what type of accuracy you want, which we're passing through as default. You can set a movement threshold if you want, meaning that if you want to be able to filter out data that you don't need, meaning, I want to know when they walk a block, not when they take a step. You can set a movement threshold. Beyond that, you have to handle two events, the status changed and the position changed. So when the status changed event fires, this method is going to handle it. When position changed event fires, this method's going to hire it. It's as simple as that. And then we go ahead and click on, call the start method of the watcher, and location service is turned on. Now this is the method that we're using to capture when location is changed. And since location works on a background thread, as you know from programming, you cannot write to a UI thread or to the UI from a background thread. So we're going to simply use this dispatcher .begin invoke to pass along the data that we receive in this method to a method that runs on the UI thread, and that's just called myStatusChanged. In here, we're grabbing the status from the event args that are being passed through and just changing a label to whether it's disabled, initializing, no data, or ready. So it's a simple switch statement. The same thing for position change. Whenever position's changed is hit, we're going to marshal it across to my position changed. And all we need to do is grab the e.position, .location, .latitude, and longitude and point it out to string. That's it. That's as easy as it gets when working with location. Now, you might not always want latitude and longitude, but you can take those and then send the lat long to a service and get back a location, specific address location in your app. Let me go ahead and run this because there's another thing I want to talk about when we reference location. I'll pop open the emulator here. So you can see it's currently turned off, and if I look at my application bar here, we have low, high, and stop. The high works the same way as the other method worked, except it's passing high instead of default. So I'm going to go ahead and click low. It's initializing the service, and it gives us a latitude and longitude. But unless you are looking for a very specific location in Princeton, New Jersey, this isn't going to help you too much. So they're sending back some fake data for longitude and latitude while you're in the emulator, which means that it makes it difficult for you to test. So you have to write a mock or somehow simulate data coming through to the emulator. Now I'm going to show you a couple examples. Now the first one is rather ingenious, but you shouldn't use it, and I'll show you why. At least in its current state you shouldn't use it. So let me go ahead and bring that up. Actually I have to bring up two projects. Let me start those. The first one is gathering the data for us, and the second one is just a Windows Phone 7 project that consumes it. So let me show you the map project first. I'll go ahead and run this. Slowly. Okay, that should come up in a minute here. Now if we look at this application, you can see it's a map of the United States. And as I move across different parts of this and double click, you can see in the upper right, it is calculating the lat long of where I'm clicking on the map. So as you drill down, you can more easily simulate. You can use aerial. Say if you're in the mountains here, you can simulate where exactly you're heading. You can see how quickly you're heading, all that stuff. Now let's bring up the project that consumes this. I'll take 1 second here. Run that. Bring up the emulator. So I need to move this over here and actually move this over here. Go ahead and turn it on. And you notice that the consumer is reading data from the service, and so I can simulate movement on my app, which is good. But you go ahead and shut these down. I can show you what the difficulty is in this app. And if it's modified, it'll work well. So if we look at the code behind for the application that's consuming that service, you'll notice that it's not using system.device.location at all. So you're able to get your latitude, longitude, and movement and all that stuff, but this will work on the simulator or the emulator, but this will not work on the real phone. When you use a mock or you use something to simulate any of the sensors, you want to be able to very easily flip a switch and have it work on the phone. So let me show you how I do that. Go ahead and close this. Let's see, bring up the application, location sample. And I use something that is really simple. I got this from Peter Torr's blog, and he used it at Mix, and it's a mock of the location services. I'll go ahead and show you what it is. I'm going to go ahead and add existing project. It's called Mix Demo Helpers. You can download this from his blog as well. It's not complete, but I'll show you what it does do. If you look at it, it takes all the classes in the real system.device location and mocks them out. He then creates a file that basically puts lats and longs in a collection and determines movement. So the time to change position, every time this is reached, it's going to go to the next lat long position in this collection and then finally end. So you can very easily simulate what you need for an application. Now, to utilize this, I only have to do two things. So first, in my location sample that we saw, I'm going to go ahead and do add a reference. I need to obviously make a reference to that project. Then in my code, I'm just going to comment out system.device.location and instead put using mixeddemohelpers.location. And the last thing I need to do is in my constructor, I need to do start Los Angeles data location dot setup. And now when I run this, that's the only two changes I made. If we look at the application as it fires up here, go ahead and start it like we did before. If we look at this, and we look at the lat and the longs that are coming through here, you'll see that it's changing. Looking at that file and changing as it's moving across. So it's a very simple way, and to me, a good enough way to simulate moving in your application. Now, it all depends on what your application does, and if you have the time, it would be great to take that map one and fix it so that it utilizes or mocks out exactly how this one mocks out the location. So you can quite simply switch out system.device.location, uncomment this, and I'm ready to roll on the phone. So remember, when you're using any type of mock to simulate any type of sensor, make sure that it's easy for you to switch from the real to the emulation, and you'll have a much easier time deploying and finishing up your app. Okay, let's go ahead and back to the PowerPoints. Next thing we're going to look at is the accelerometer, and depending on your experience, you may have never worked with an accelerometer in your life. So I want to kind of level set the accelerometer, how it works, and what you're doing with an accelerometer. So first of all, an accelerometer measures proper acceleration, which is relative to free fall. What that means is you need to be able to provide accurate responses to measurable increments of movement with the phone. So you need to be able to determine whether it's slightly moving right to left, or shaking right and left, or front and back, or you're turning, in a circle, and you need to be able to convert those into useful signals for your application. So the three things we're measuring are the three axes that are required for this accelerometer. So the y-axis, which runs up and down through the phone, the x-axis that runs back and forth through the phone, and then the z-axis that runs right in the middle of the phone from you to the back, right through the center. But I wanted to get a little more detail in exactly what this means and the measurements you're going to be getting. So I wanted to talk about the drag on the phone and the readings you're going to get on the phone. We'll start with, first, if you have the phone sitting on the desk, and you can do this with your phone right now. If you have it sitting on the desk, straight up like you see, you'll notice that the x-axis is across the top, left to right, and the y-axis is up and down on the side. Now the arrow shows the pull, and the readings that you will get back from this are x0, y -1, and z0. And the reason, even though you're not moving, that you have a -1 is because of the Earth's gravity. The Earth's gravity is always going to pull 1g. Now, when you actually get these readings on the device, they're not going to be exactly this. They're going to fluctuate slightly around these numbers, but for purposes of this, you'll get 0, -1, 1. If you flip the phone over, you'll have 0, 1, and 0. So this is an easy way for you to determine how they're holding the phone. If we look at if it's laying flat, laying with the screen facing up, this is where the z-axis gets the pull. So remember, the z-axis, as it shows in the upper right-hand corner, is coming right through the phone. So with the phone laying down with the screen facing up, you'll have the 0, 0, and -1 reading with the accelerometer facing down, again, 0, 0, and +1. And then finally, if you're holding it on its side, this is where the x-axis kicks in. So -1, 0, 0, and then +1, 0, 0. And that's really as simple as it gets. Those are the three readings you will be working with when you're working with the accelerometer. Now, let me go ahead and show you some code, and I'll talk about that a little bit more. Open up another project here. Pop that open. So again, this solution, if we look at the main page, is just going to show me, once I start it, the X, Y, and Z axes of the page. So I'm going to close this down, and we will look at the code behind here. If we look at the Start-Stop button, we just want to look at a few things. First, we're just going to check to see if the accelerometer is null. Up here, we've created an instance, just like in location, of an accelerometer. And if it's not already started, we're going to go ahead and new up an instance of accelerometer. And it's even easier than the location, because now all we're measuring is reading change. So when this event fires, this reading changed event fires, we're going to pass it to the accelerometer readings method, which we'll look at in a second. The rest of this is we're catching some errors. If we get any of the errors, we're sending it to a text block. If it's not null, we're just setting the fact that it's stopped. So the only thing that's important, again, is down here, this my readings changed. Again, we're using dispatcher.begin invoke to move it to the UI thread, and we're getting back the X, Y, and the Z readings from the phone. And that's it. That's as easy as the API gets. Now, this is where it may get a little tough, because what you need to do here is utilize all the years of schooling that you had in trigonometry and physics and all that to take these readings and determine how the phone is being used. And what I mean by that is people don't take it and stop really quickly using the phone. They move it. So you're not only looking at what the X, Y, and Z coordinates are at any given time, but how are they moving it? How quickly are they moving it? Are they moving it back and forth really slowly, or are they doing it quickly like a shake? And those calculations are done by you using, like I said, trigonometry and other things to determine how quickly they're shaking and in what direction, or multiple directions they're shaking it. But the API to the accelerometer sensor is quite simple. Okay. Let's go ahead and head back to the presentation. Okay, the last thing we're going to talk about is launchers and choosers. These are the APIs that allow you to get to most of the functionality on the phone. They are built-in APIs that let you get to things like the phone, the camera, the contacts, SMS, and launchers will launch functionality like the camera, like the phone. Choosers allow you to select data back. So a good example would be email. If you want to send an email, a chooser allows you to grab an email from someone you have in contacts, and then the launcher allows you to launch an email client to send the email. The same thing for SMS. The chooser allows you to grab a phone number from your phone book, and then the launcher allows you to send a text message from it. Again, as we talked about, utilizing launchers and choosers causes your application to tombstone because you're going outside of your application. So make sure you understand that when you're working with launchers and choosers. These are the launchers and choosers that you have from the camera capture task, phone number chooser task, etc., SMS, which we already talked about, email compose task, to media player launcher. There's also a marketplace launcher. The marketplace launcher allows you to launch the phone to the marketplace to your specific app, and you would use that when you are alerting them to their trial period being done, and you can automatically send them to the place in the marketplace where your app resides so they can purchase it. So that's how launchers and choosers work. So isolated storage is a piece of cake. There's only a couple things you have to be aware of. So isolated storage is found in system.io. Isolated storage. If you've ever done any system.io create, reading memory streams, all that stuff, it's exactly the same. It's just the fact that it's an isolated storage on the phone. So there's two flavors, two types. There's isolated file storage, which allows you to save program data in the phone, stuff that works as part of data they're saving. So if you're doing pictures, it saves picture data. If it's a checking book application, that would be the registers that you have in an application. And you also have setting storage. So there's an easy way to utilize isolated storage to have settings saved. So the username and password of an application, or check boxes of what colors or themes to use, that type of stuff is saved in setting storage and isolated storage. Now, these we have a couple things in the hands-on lab that allows you to work with this and work through it, and have some really cool helpers that will help you along with it as well. But isolated storage is no different, or I should say very similar to how you utilize system.io and regular namespace. So that's the end of the third session.